Hey guys, welcome back. This is part 2 of solving quadratic equations using factoring. And these are some of the harder problems that are on the back of the sheet. We're going to work through them. They're just harder because there's a little bit more work that needs to be done in order to meet the criteria of making the quadratic equal to 0 and also getting it into completely factored form. So we take a look at this guy, we can see this is clearly a quadratic. The highest exponent is 2, and this is an equation because of the equal sign. And the directions here as well as before are to solve. So we want to figure out what x is in order to what x would have to be in order to balance this equation. We also talked about in part 1 how we end up typically with two solutions. We could end up with one solution or none, but for most of these, they're going to be 2. Some of them might be 1. Very few, if any, are going to have none. Okay, so let's take a look at this. We're going to have to meet the 2 criteria we talked about in part 1. This equation is going to have to be equal to 0. Okay, in order to do that, we're going to have to move these 2 terms, the x squared and the negative 3x. And you can do it in 2 steps if you want to. We're going to actually do it in 1 by subtracting x squared. That's going to help us move it. Now we also know with an equation, whatever you do to one side, you have to do to the other. So we're going to subtract x squared from the 2x squared. And notice I put it underneath the term that is like the one that I'm moving. So negative 3x, in order to move that, we're going to add 3x. Okay, and I'm going to actually add that to the other side. And I'm putting it underneath the negative 4x because those are like terms. So I'm going to draw my line here. We can now do the work. 2x squared minus x squared is x squared. I bring down the negative 12, and then I have negative 4x plus 3x is negative x. And now I get 0 because everything on the right-hand side cancels. And I take a look at this trinomial, and it still looks a little bit out of order. So before I even begin or before I go any further, I'm just going to put it in order in standard form, x squared minus x minus 12. And now I'm ready to take the next step, which is to get this in completely factored form. Okay, so I look at it. I could tell there's no GCF here. This is a trinomial. It's a type 1. So it's going to break down to 2 binomials. And the technique that we're using here are factors of negative 12 that add up to be negative 1. So negative 4 and positive 3 would achieve that. And now I can set these factors equal to 0. And I end up with x equaling 4 and x equaling negative 3. Okay, and we're going to take a look and work through most of these on the back because they are all a little bit different and unique. Taking a look at number 10, we can see here this is hey, maybe it's not a quadratic. This is actually a cubic, but we can still solve it using this idea where the equation is equal to 0, and we can still get this into a factored form. Because when I look at this guy, I see that the leading coefficient's negative, and I can see that there is going to be a GCF between these 2 terms. So I'm going to take out a negative 3x, and what's left in the house is going to be x squared minus 9. And remember, we said that this side has to be factored completely. So when I look back in the house, the other thing I notice is that I have a difference, subtraction, of 2 perfect squares. X squared is a perfect square of x, and 9 is a perfect square of 3. So I can factor this further. We bring down our monomial factor of negative 3x, and now I figure out x times x would give us x squared, a positive 3 and a negative 3 would give us a negative 9. Now everything is factored completely, and I can use the zero product property that says if these 3 things when being multiplied equal 0, then the first could equal 0, the second could equal 0, or the third could equal 0. So here I would divide both sides by negative 3. 0 divided by negative 3 is 0. Here I would subtract both sides by 3. Here I would add both sides by 3. So here this guy actually has 3 solutions because it's a cubic. Okay, this really isn't quadratic, but we treated it like one, and we can still apply what we learned about quadratics to this guy because it's factorable. Okay, so just looking at some variety here, looking at number 11, obviously this is not equal to 0. Okay, so I'm going to subtract 4 from both sides. Okay, and this is not in factored form because of this minus 4. These are factors, these are being multiplied, but this minus 4 together with those is not a factored form. So what I can do is I can make this look like some of the other ones that we've seen. I'm going to distribute this x in here. I get 2x squared plus 7x minus 4 equals 0. And now that looks very familiar. That looks like a type 2 trinomial that can be factored into 2 binomials. 2x squared is created by 2x and x. It's the only combination that works. And now I'm looking for factors of 4, which are 1 and 4, 4 and 1. I'm going to go with a 1 and a 4. And I want these to add up to be positive 7, so I'm going to do a positive 8 on the outside and a negative 1 on the inside. And now I set my factors equal to 0, and I can solve. Okay, for this one I'm going to add 1 to both sides and divide by 2. And this one I'm going to subtract 4 from both sides. And that gives us our solution for number 11. 2 solutions. Okay, keep cruising here. Looking at number 12, presents all these problems, or present different problems, different issues. This actually isn't a quadratic either. This would be a cubic as well, but it is equal to 0. Okay, we're going to still apply what we learned about quadratics to this guy as well. It looks like these are factors. But remember, we said we want them to be completely factored. So this guy's okay. The 2x minus 1, that can't be broken down any further. But this guy is a trinomial. That's a type 2 trinomial. And I'm going to try to think of factors of 6, which would be 6x and x. But if I think about that with a 1 and a 5 and a 5 and a 1, I wouldn't be able to create a negative 13. So I'm going to go to the next 2 factors, and that's what makes type 2 trinomials a little bit harder. And now I'm going to look for factors of a 5 and a 1, or a 1 and a 5. And one of them has to be positive, one of them has to be negative. So I'm going to go with a 5 here and a 1 here. And I want a negative 15 on the outside. Sorry, let's say negative 15 on the outside. And I want a positive 2 on the inside to create my negative 13. So these are just type 2 trinomials. I have 3 factors that I need to set equal to 0. And now I have to solve those by adding 1 and dividing by 2, subtracting 1 and dividing by 3, and adding 5 and dividing by 2. Okay, last couple examples here. We're going to finish up with these last 2, number 13. Okay, and it's the same idea here. Okay, what we're going to do is we're going to look to see, is this equal to 0? Check. Is this in factored form? No. So we go to that master factor plan. This guy does not have a GCF, but it does have 4 terms. And what we learned is if it has 4 terms, we might be able to factor by grouping. So I'm going to group the first 2 together. That negative, this negative here, it belongs to the 98. And make sure there's an addition sign in between. And now I'm going to look for a GCF in my first two terms, which is x squared, which would leave me with 2x plus 1, and a negative 49, which would leave me with 2x plus 1. And now I can see there's a common binomial here in both of these terms that we're going to take out. And that leaves us with x squared minus 49 equals 0. All right, so how do you know when you're done? How do you know when you can set those factors equal to 0? Well, we got to check and we got to make sure, are these factors completely factored? This guy is 2x plus 1. There's not a whole lot we can do there. But this guy is a difference of two perfect squares, so we can factor that further. Okay. So what we end up getting there is setting these three factors. So this is going to have three solutions again, equal to 0. And we end up with subtracting 1, dividing by 2, subtracting 7, adding 7. And we've got one more to go here. And I don't want to skip it because I think there's going to be some stuff going on in here. This is equal to 0. It has 4 terms, so we're going to factor by grouping. And let's see why this one might be a little different. It might not be. I don't really remember. But here we're going to factor out an x squared, and I get x minus 6. And here I'm going to factor out a negative 9, and I get x minus 6. So this has a common binomial of x minus 6. And this is very comparable to the one before it, because now I got to notice I have a GCF. I'm sorry, I got to notice that I have a difference of two perfect squares. So I get x minus 6 times x plus 3 times x minus 3. And now I can set those three factors equal to 0. And I get x equals 6 by adding 6 to both sides, x equals negative 3 by subtracting 3 from both sides, and x equals positive 3. Okay, and there it is. So that wraps up part 2, solving quadratics by using factoring. Even though not all of these are quadratics, as we see, these are third degree. These are actually cubic. You could still use this idea. That's what's making these problems a little bit more challenging, honors level problems. You'll see these in Algebra 2 for sure. Okay, but this is a really important technique. It's not the only technique that we use to help us solve quadratic equations, but it is really efficient and convenient when you can factor the given quadratic. All right, we will look at some other techniques for solving quadratics that don't require factoring, and maybe you'll like some of those, but this is an important one to remember, guys. Good luck with your homework, and I'm signing off. I will see you guys next lesson. See ya.